A powerful cyclone can look like one solid spinning storm, but inside the core it may be rebuilding itself. In the strongest tropical cyclones, the ring of violent thunderstorms around the eye is called the eyewall, and it contains the most destructive winds. An eyewall replacement cycle begins when outer rainbands organize into a second ring of thunderstorms around the original eyewall. This creates concentric eyewalls, almost like two circular walls inside the same storm. In some intense systems, the original eye can be only 10 to 25 kilometers wide, which is about 6 to 16 miles. The new outer eyewall often forms farther out, roughly 30 to 60 kilometers from the center, or about 19 to 37 miles. That outer ring needs warm, moist ocean air to power its updrafts. As it strengthens, it intercepts the inflow before that energy can reach the inner core. In plain language, the outer eyewall steals the fuel from the inner eyewall. Between the two rings, a moat region can form where air sinks. That sinking air suppresses thunderstorms and helps cut off the inner eyewall from moisture and momentum. The original eyewall then weakens, decays, and can collapse. During this transition, the storm often looks less intense by peak wind speed. Central pressure may rise slightly, and the tight pressure gradient near the tiny inner eye relaxes. Because the fastest winds were packed into a small ring, losing that ring can temporarily lower the maximum sustained winds. But this is not always good news. The replacement eyewall is larger, so the storm's strongest wind zone spreads outward. After the inner eyewall disappears, the cyclone can have a much larger eye and a broader wind field. If the ocean remains warm and wind shear stays low, the new eyewall may contract toward the center. As it contracts, the storm can spin faster again, pressure can fall, and re-intensification may follow. A full eyewall replacement cycle commonly lasts 12 to 36 hours, though timing depends on storm size, ocean heat, and the surrounding atmosphere. Forecasters watch these cycles closely because a storm may reach land while it is weakening, expanding, or strengthening again. Detecting the change is not simple on normal infrared satellite images. Thick upper-level cloud can hide the lower structure of the core. Microwave satellite imagery helps by seeing through that cloud shield and revealing rainbands, ice, and heavy liquid water. That is how forecasters can identify double eyewalls before the pattern is obvious in standard pictures. Radar can also show double ring structures when a cyclone moves close enough to land. The biggest public safety lesson is that a lower category during replacement does not mean a harmless storm. A wider wind field can push more ocean water toward the coast for longer, raising storm surge risk across a larger area. Destructive winds can also reach farther inland before the cyclone spins down. Historical storms, including severe Australian cyclones and western North Pacific typhoons, show how these internal rebuilds can complicate forecasts. The key is to focus not only on the peak wind number but on the whole storm footprint. Eyewall replacement is a reminder that intense cyclones are changing machines, and sometimes a temporary drop in wind speed is part of a larger, more dangerous evolution.